This is lesson 9 warm-up, so take a second and do this work. Lesson 9. So this problem, we're distributing a negative 2/3 to what's inside our parentheses, but we don't want to have to deal with the fraction. So what can we do to get rid of that fraction? We can multiply both sides by the denominator. Multiply both sides by the denominator. So when I do this, I get 3, and my 3's cancel out. I'm left with whatever in my numerator. In this case, it will be a negative 2. I'm going to have to distribute this negative 2, and 3 times 10 makes 30. So distributing a negative 2, we get negative 8x. Negative 2 times 5 makes negative 10 equals 30. Add 10 to both sides. Negative 8x equals 40. Divide by negative 8. And x equals negative 5. So you guys can see that. Our next problem, we can just distribute. Let's write down our 13x first. Negative 4 times 2x makes negative 8x. Negative 4 times negative 5 makes positive 20, and that equals 15. We've got a little like terms to combine. 13x and negative 8x make 5x, so we've got 5x plus 20 equals 15. We can subtract 20. 5x equals negative 5. Divide by 5, and we get x equals negative 1. Skip homework questions. Today we're going over lesson 9. We're going to solve one-step and multi-step linear inequalities. So we solve this just like we would regular equations with a couple differences, and we'll describe these differences as we go. So let's talk about this. We read these equations. This would be in their final form. We read them and we can call this symbol the inequality symbol of how it's opening up or eating. So we'd say this is open to the x, or it's eating the x. And we can think of this symbol as always wanting to eat or always wanting to be open to the bigger term. So I would read this as x is greater than 4. Now, instead of saying x, though, we always say all real numbers. So we read this to be all real numbers. That's what the x means, and we read that first. So all real numbers greater than and in this case it's 4. Okay, so all real numbers greater than 4. When we graph this, on a number line. To say that we want numbers that are greater than 4, if I had a number line, I'd have 3, 4, and 5. To say that my solution would be numbers that are greater than 4, I'd put a circle at 4 because that's where I'm going. And numbers that are greater than 4 would be numbers to the right. Okay, now the good question is does this include 4 as a solution? It doesn't include 4 as a solution because we don't have an equal sign. That's why we call this an open circle. So when we see an open circle, we just know that we're either greater than or less than. In this case, it's greater than because we're going to the right, but we're not including 4 as a solution, as an answer. We can remember from yesterday that we said instead of saying all real numbers, we've got a shortcut to that, and that is the R with a double leg, so that's all real numbers. We would read this the same way. We're going to start with our variable. All real numbers, it's open to the variable, so all real numbers greater than 4 this way as well. All real numbers greater than 4. So we read them both the exact same way. Our graph, we're at 4, and our graph is going to look the exact. So this will be an open circle again. All real numbers greater than 4, open circle, and greater than 4 goes to the right. We'd read this next one as all real numbers less than 4 because it's eating the 4, it's open to the 4. We always start with our variable, so all real numbers less than 4. All real numbers less than 4. What are numbers that are less than 4? Numbers to the left. For the next one, we start with our variable again, and we say all real numbers less than 4 because we're eating the 4, so this is all real numbers less than 4. 4 less than 4, open circle. Now, the difference between this one and this one is you can see we have a little equal sign with this inequality. So we would read this as all real numbers greater than or equal to, and in this case our number is 4. So if it's greater than or equal to with the equal to symbol, we use what's called a closed circle or a filled in dot. A closed circle, we close off that circle. And when we see a close off circle, that means that 4 is a solution to this system. We're not just looking for numbers that are bigger than 4, like these top two, numbers that are greater than 4. We're looking for numbers that are greater than 4 and that are equal to 4. All of that's a solution. Same thing, doesn't matter what side our variable's on, as long as we're eating the variable. We start with the variable. We would read this the same. All real numbers greater than or equal to 4. Same thing, closed circle going to the right. Numbers that are greater than 4 are on the right. Our next one, we can see that we're eating the 4, so we're just going to say that's less than. All real numbers less than or equal to 4. All real numbers less than or equal to 4. So we're at 4. Closed circle because we're equal to, and less than goes to the left. And our last one, same thing, all real numbers less than or equal to 4. We're eating the 4. So all real numbers less than or equal to 4. 4, closed circle, we have the equal sign, we're including the 4 as part of the solution. So, solving an inequality that's in an equation. We've got this equation, 5x plus 3 less than or equal to 13. We're going to solve it just like we would. We're going to subtract 3. I get 5x is less than or equal to 10. Divide by 5, and I have x less than or equal to 2. And now I don't read that as an x. Get in the habit of saying, instead of x less than or equal to 2, get in the habit of saying all real numbers less than or equal to 2. So where's our number at? If we were to make a number line, we'd say we've got the number 2, I'd have the number 1 here, I'd have the number 3 here. Less than or equal to, we're going to use a closed circle. So I'm going to close that circle, and numbers that are less than go to the left. Now, this next example is a little bit different. With this next example. And I want to change this. Let's change this from being in. Let's change this from being an or equal to just being a less than. How's that? That looks better. So when we change this, we say we can say we're going to do the same thing. We're going to add 3. We're going to add 3. Sorry. Sheesh. We're going to subtract 3. We're going to get negative 5x is less than 10. Now, when we divide by a negative, because I'm going to have to divide by a negative 5 here, divide by a negative 5 here, I have to reverse my inequality symbol. So I change, instead of opening to the right, now I open to the left. We still get, now we get negative 2. And I would read this as all real numbers greater than negative 2. So now what's the difference between our symbols here? We're at negative 2, so what's to the left of negative 2 would be negative 3. We'd have negative 1 here. Greater than negative 2, well, we don't have the equal symbol, so we're going to be an open circle, and greater than goes to the right. So the whole idea here that we need to remember, so star this, is that when we divide by a negative, okay, we divided by a negative, we need to flip the inequality sign. So when dividing by or multiplying by, it's the same thing, but most of the time you'll see it as dividing by. When dividing by a negative, flip the inequality sign or symbol. Okay, so we flipped it from opening this way to opening this way. And that's our lesson. Our homework is homework 9.